do problem 31 on page 146. Let me read the problem. It says, a 4,500 kilogram helicopter accelerates upward at 2 meters per second squared. What lift force is exerted by the air on the propellers? Okay, so here's our helicopter. It's got a little door on it. It's got a little truss thing like this. Got a little tail thing. It's got this. Got little propellers going like this. It's got a little rail thing like this. And we're just about to push somebody out. All right, now somebody's sitting in here in the controls. It's got a little stick for them to hold on to, and there we go. We're flying our helicopter. Not bad. Now, it's accelerating. It has a mass of 4,500 kilograms, and it's accelerating up. A equals, what did it say? 2 meters per second squared. 2.0 meters per second squared. And what are we trying to find? We're trying the force of lift. The lift force, right? The propellers push down on the air pushes up on the helicopter. We call that lift on the blades. So, solve. What did I just do? I just did step 1 of the procedure. Now I'm going to do step 2. Draw a free body diagram. Do I want to draw all this again? No. So I'm going to draw it, go like this. Just go like this in your imagination. There's my helicopter. And here's the little drops of blood from the pilot. All right, now. Okay, so gravity is pulling down on the helicopter. Force of gravity, we call that force of gravity is equal to mg. I usually just write it as mg. Now, the blades swirling around give us lift. And I'll just call that F sub L. You can make up your own subscripts for the force. If it's the force of lift, just call it F sub L. And then, so there you go. Now, what did I just finish? Step what? Step 2 of the procedure is drawing the free body diagram. What's step 3? Yes, XY. Do we really need X? Not really. There's no forces in the X, but there is a Y-axis. What's step 4, the most important one?
Newton's second law.
Sum the forces. Yeah, Newton's second law. Sum the forces. Do we care about the X direction? No. So sum the forces in the Y direction equals MA in the Y direction. These are a set of instructions. Add up the forces in the Y direction. That's what it's telling you to do. So look at your free body diagram. It's that lift force from the propellers plus the force of gravity, but instead of plus, what do we use? It's going down. Negative y. Adding a negative means we're subtracting the weight equals ma. Now what am I solving for? Solving for the lift. Now I'm doing step 5. I'm solving for my unknown, which is this. Because I know this, I know this, I know this, I know this. So the force of lift is equal to ma plus, add it to the other side, mg. So what basically this says is that this is 4,500 kilograms times the acceleration, 2 meters per second squared, plus 4,500 kilograms. And you could factor it out and do it a little bit differently, but I won't, times 9.8 newtons per kilogram. Yes, you can use meters per second squared if you want, but it's a gravity field. It's how much force you get per unit mass. So you do the arithmetic on your calculator, and you get something that will round off to 53,000 newtons. Okay, well, there's 9. Now, here's what this means, though. The lifting force from the propellers on your helicopter has to do 2 things. It has to support your weight, and it has to have even more force to give you an upward acceleration. But I think you see how the procedure works. Step 1, 2, 3, 4, 5. Do it every time. All these problems are different, but you solve them the same way. Okay? And that's how I want you to do the take-home test problems. Follow the procedures best you can. Any questions? That is all.